All right, let's put this in our calculator. You guys all did that part, right? And I think you only see two of them. Is that what happened?
Yeah, that's all I see.
All right. So x to the fourth minus 5x to the third plus x minus 5. All right, so we graph it and we only see two of them. Okay? Any issues with that? Okay, so I go to my table. -1 and 5 are the two zeros. We're good on that? All right. So let's move these over. Give me some room here. So what were they? -1 and 5, right?
Yeah.
So we've got those right there. Okay? So does it matter which one I start with to do my synthetic division?
No.
No. I know there's two more left because why? How do I know there's four?
The leading coefficient.
That leading coefficient, that leading term has a degree of 4, right? That means there's going to be 4 zeros, and I only see two of them, so the other two are imaginary. Okay, so I have to do the synthetic. Everyone with me on that?
Yeah.
Okay. So I put 1 in for the x to the fourth, -5 for the x to the third, but what's missing? X squared, right? So I put a 0 at that spot. Did we remember that? We got 1 for the x, and then our -5. Drop the 1 below. -1 times 1 is -1. Add them, -6. -6 times -1 is +6. So +6 there. -6 there. So -5. When I add, -1 times -5 is +5. I get my 0, so I did my work right. Now I put the 5 next. Drop my 1. 5 times 1 is 5. 5 times -1 is -5. And 5 times 1 is 5. So I'm supposed to get the zeros for remainders on that, right? If I don't, I did something wrong. I gotta check my work. Questions up to this point? All right, now remember, this started out originally as x to the fourth. Once I did synthetic division once, went down to x cubed. After I did it a second time, this bottom row is an x squared, right? -1x plus 1, right? That's the equation. So this is my A, this is my B, and that's my C, right? For the quadratic formula. So that's what I have to do to finish up, is use the quadratic formula. Okay? So I've got x equals -b, oops, not squared, sorry, plus or minus, my b squared's in here, right? -4 times a times c over 2 times a. All right? Questions on substituting in? All right, so we get a +1 plus or minus square root of something over 2, right? -1 squared is 1, and -4 times 1 times 1 is -4, so that's a -3. All right, so the only thing I can do with that radical is pull what outside of it? The I. So there's my other two zeros. 1 plus I radical 3 divided by 2, and 1 minus I radical 3 divided by 2. So here's my 2, 3, 4 zeros. Questions? That helped those of you that were struggling a little bit. Okay. So, answers to homework. All right. I don't know why I forgot to put 1 on there, but I'll give you the answers in case you want to go over any of them. Number 1 was 3, -5, -2, and positive. I'm sorry. 3 is the number of zeros. -5, -2, and +3 are the answers. Number 3, there are 5 zeros, 0 and 1. Oh, 0 works multiple times. I think 0 works 3 times. Did it bend as it crossed the 0? The graph? You guys, anybody sketch the graph? All right. So 0 works 3 times of the 5 zeros. And then 1 plus I radical 2 over 2. I think what it is 2 plus I radical 2 over 2. And 2 minus I radical 2 over 2. Right? If you went all the way. Very similar to the warm-up. Number 5, there's 4 of them. -1 and +2. And then 1 plus I radical 3 over 2 and 1 minus I radical 3 over 2. Okay? Like our warm-up problem. 7, there is, what's it asking me? Find all the zeros of it. Okay? So, -1, +1, +2, and +4. You can see all 4 of them. For number 9, you can see all 4 of them. -2 works twice because it bounced off at -2. 1 and 3. Number 11, -3 and -1 are the ones you can see. +2i and -2i are the imaginary ones. For 13, -4 and -1 and +2, you can see on your calculator of the 5, and then I radical 2 and -I radical 2 are the 2 imaginary ones. 15, you were looking at a picture of the graph, and it said, determine the number of imaginary zeros. Okay, it says the degree is 4, so it's supposed to be 4, and you can only see 2 of them from the graph. Let's see if I got a picture of it here. There it is. So we're looking at 15 here. It tells us the degree is 4. We can see 2 of them crossing the x-axis, so that means there's going to be 2 imaginary ones, okay? And then here it says degree 2, and it doesn't touch the x-axis at all, so there's 2 imaginary answers. Okay? Any of those you want to go over?
11.
Okay. So let's go back to 11.
Let me get my hands down.
All right, so when I look at my calculator, that's this one, right? With the 12 at the end. All right. So I already got the x to the 4th in there. Minus 1x cubed, right? Plus 7x squared minus 9x minus 18. All right, we're looking for 4. How many times does it cross or touch?
Twice.
Just twice. Looks like a -1 and a +2.
I got negative in the wrong one.
Oh, I did?
You put in 12.
I put in 12. Sorry. Thanks for correcting me.
Nice, Taylor.
So it's one that ends in the 12, right?
Yeah.
And I had said that earlier. Sorry about that. Plus 4 x cubed. I got the 7 right, didn't I? That was there too, wasn't it? Plus 16x plus 12. All right, I'm still looking for 4, right? Looks like -1 and -3. Was that right?
You did everything wrong. I got -1.3.
All right, let me look. Maybe it's not in the table. There's -1. There's -3. So maybe you have, you put something in wrong in the calculator.
This is on me. This is on me.
All right. Do I need to go any further, Kevin?
No,
Okay.
I just wanted to see if I did something wrong, but I see what it is.
All right.
What'd you do? I put.
Anything else? Okay. So today's doing the same stuff, but also going backwards. Okay? Complex conjugates is what we're talking about first. All right. Pairs of complex numbers of the form a plus bi and a minus bi, where b is not equal to 0, called complex conjugates. In example 2, notice that 0's 2i and -2 are complex conjugates. This illustrates the next theorem. Okay? So if a polynomial function with real coefficients and a plus bi is an imaginary 0 of f, then a minus bi is also a 0 of f. What they're saying there is, if like 2 plus 3i is a 0, 2 minus 3i is also a 0. They come in pairs. If negative I is a 0, then positive I is a 0. Okay? They always come together. Same thing with radicals. If I had a radical 2 as a 0, negative radical 2 is also a 0. If I had 3 plus the square root of 5, 3 minus the square root of 5 is also a 0. Okay? So what we're going to do today is they're going to give us the zeros, and we have to figure out the polynomial that goes with it. And you guys did this earlier this year. Okay? So this really isn't anything new, but we only, spent maybe a day on it. So we might have forgotten. Okay? So here's example 1. It says, write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1 and zeros of 2, -3, and 3/4. Okay, the way we start these, and once I do this, maybe this will come back to you. We start these, we have to write the factors of the zeros. So I always start as x minus. Okay, so since there's 3 zeros, I have to have 3 factors, and they always start x minus. Okay, and then I just put those numbers in. So I put x minus 2. What's x minus -3 going to end up being? Yeah, so this minus a -3 ends up making it x plus 3. Now, when you have the fractions, the denominator goes in front of the x. So what do I put in front of the x? The denominator is what? Which one? The 4. Yeah. So the 4 goes in front of the x. Then you write your minus. And then the numerator comes after the minus. So the 3 is the numerator. So that's how we write that factor. That way you won't have any fractions in your answer. So don't write x minus 3/4. Write it as 4x minus 3. Okay, Nick? Now, you guys know what to do from here. How do I multiply x minus 2 times x plus 3? We just FOIL it, right. From here, it's stuff you've already done. So I go x times x for first, x times 3 for outside, -2 times x for inside, and -2 times 3 for last. Combine your like terms, so you get x squared plus 1x minus 6. And then you have to multiply it by that third one. Okay? Questions so far? So we take the x squared times the 4x and get 4x cubed, and the x squared times negative 3 and get negative 3x squared. And then the middle one, x times 4x is 4x squared, and I like to line up my like terms. And then x times negative 3 is negative 3x. And then I take the negative 6 times both of those. Negative 6 times 4x is negative 24x. And negative 6 times negative 3 is positive 18. So I've got my like terms lined up, so now I can finish it up. So 4x cubed plus 1x squared minus 27x plus 18 has a 0 of positive 2, a 0 of negative 3, and a 0 of 3/4. So that's the polynomial that goes with those 3 zeros that we started with. So we're just going backwards today. That makes sense?
Yeah.
So always start how? X minus. Yeah, always in the beginning, right? Now, when you have complex ones, okay, they only show you 3 of them. But what did we just say before this? The imaginary ones and the radical ones have come in what? Pairs, right? So they're going to want you to remember what's the pair with positive 2i? Negative 2i. What's the pair, conjugate pair with 4 minus radical 6? 4 plus radical 6. Okay? So they won't give you all of them, but you have to realize that there's, in this case, 2 others. There's a total of 5 of them. Okay? Any questions on that? All right, sometimes we forget about it because we get in a hurry. All right, so there's actually 5 zeros for this. All right, so again, we always start x minus. So I'm going to put the 2, and then x minus positive 2i, and x minus negative 2i. Well, again, what's minus a negative 2i? Plus, and then x minus, and you just put 4. So this one's going to have 3 terms when you add the x minus. 4 minus the square root of x, and x minus 4 plus the square root of x. Or 6, I mean. Okay? So that's what it looks like when you get started for this type of problem. Any questions? All right, Caleb. They come in pairs. All right, so that the complex numbers come in pairs, and these irrational ones with the radicals come in pairs always. All right. Now, this is important. You must multiply these 2 together when you start. You must multiply these 2 together. Okay? Because when we multiply the 2 complex ones, what's going to end up happening with your i's? Everything's going to cancel. There won't be any i's left. When you multiply these irrational ones, these ones with the radicals, what's going to happen to those square roots? They're going to go away. Okay? So they will be eliminated, but you have to do it in that order. Okay? Put those together. So we won't mess with this x minus 2 for a while. Okay? I want to get the answer to this green box problem. Okay? Then I want to get the answer to the blue box problem. You with me? Okay. So for the green box, I go x times x. We're just spoiling it. X times positive 2i. And I just always do it ix. I do it in alphabetical order. But if you wrote xi, it's not wrong. And then negative 2i times x. And look what happens to those 2. What happens to those middle 2? They're going to go away. They're going to cancel, right? That's always going to happen. And then what's negative 2i times a positive 2i? negative 4i squared. Right? And what has happened in the past when we saw an I squared?
Reverse the sign.
Versus the sign, right? Because I squared equals negative 1, remember?
Yeah. Yeah.
So here's what we would do. We would cross out the I square and change it to a plus 4, right? Because it's like negative 4 times negative 1. Okay? So I still have my x minus 2. That's still there. We haven't done anything with it yet. This green answer is x squared plus 4. Okay? So the i's are gone. That's what's supposed to happen. Now let's work on the blue box problem here. Now, there's 3 terms in each one, right? So how many terms after I multiply them together? I'm going to go x times all 3, negative 4 times all 3, and negative radical 6 times all 3. How many is that going to be? 9. Yeah, it's going to be 9 of them. All right? So we're going to go x times x times negative 4, and x times radical 6. Any questions on the first 3? Then I'm going to take negative 4 times x, and I'm just going to line up the like terms when I see them. Negative 4 times negative 4, and negative 4 times the square root of 6. There's the next 3. Okay. Then I'm going to go negative 6, radical 6 times x. So what happens to those 2? They go away, right?
Yeah.
And then I go negative radical 6 times negative 4, which is a positive 4 times the square root of 6. What happens to those? They cancel. All right? And what's negative radical 6 times a positive radical 6? What is the square root of 36? 6, right? So this is basically a negative 6, right? So all the radicals are gone, as you can see. So our blue answer is x squared minus 8x. What's 16 minus 6? 10. So now I have these 3. I have 2 binomials and a trinomial I have to multiply. Questions up to this point? Sydney. Okay. So the i's go away and the radicals go away. Now it's just a normal algebra 1 multiplying everything together. Okay? Can I multiply all 3 of them together at once? No. So it doesn't matter now what order though. It makes a difference up here. You've got to do the i's together, do the radicals together so they go away. But from here you can do the x minus 2 times the x squared plus 4 first, or you could do the x squared plus 4 times this trinomial, the blue one, first. It doesn't matter. Okay, that's up to you. Okay? Yeah. So, I'll just finish it up. Again, I'm taking my time, but these do take a little bit more time because you got this multiplication you got to do. I'll just do these first 2 next. So I got x times x squared, x times 4, negative 2 times x squared, and negative 2 times 4. Oops, that's a negative 8. Right? Are there any like terms? No. So even though it's not in the right order, I'm just going to leave it like that and go from there. Once I finish up, I'll put everything in the right order. Okay? All right. So I'm going to do x cubed times x squared x cubed times negative 8x, and x cubed times 10. Then we go 4x times x squared, which is 4x cubed, right? And 4x times negative 8x is negative 32x squared. And 4x times 10 is 40x. Okay? Then we go negative 2x squared times x squared is negative 2x to the fourth. So that's going to go with this one. And negative 2x squared times negative 8x is a positive 16x cubed. And negative 2x squared times 10 is negative 20x squared. And then negative 8 times x squared is negative 8x squared. And negative 8 times negative 8x is a positive 64x. And negative 8 times 10, negative 8. So now I've got it in the right order and everything's lined up, right? So our final answer is x to the fifth, which we were expecting because we had 5 zeros, right?
Yeah.
Negative 8 and negative 2 is negative 10 x to the fourth. 10 plus 20 is 30 x to the third. 32 and 8 is 40 and 20 is 60. And 104.
Well, that was quite a long call.
Yeah, takes some time. Is it that difficult?
No,
No.
it is. Just time.
It just takes some time. You guys can handle it. Okay?
Yeah.
So remember, come on, focus for a minute here. Last thing here, remember, if there's a positive 2i, there's also what? Negative 2i. If there's a 2 plus 3i, there's a 2 minus 3i. If there's a 4 minus the square root of x,
4 plus the square root of
always start how? X minus for your factors.
Yes.
Okay, don't forget. That's the part that a lot of us will forget. The x minus in front. There you go. Yeah.